This time we have a circular blank like this, and this blank has very small thickness. From this blank we want to make a product like this. So this one is a height and it has a small thickness here, and we have a diameter equals to d. So if you perform this operation with the top open and base, we have a solid base and the walls are solid. That is called as deep drawing operation. So in deep drawing operation, the height h must be greater than the diameter by 2. Then it is called as deep drawing operation. For this case, we have a blank here. So diameter of blank will be equals to dB. This we called as diameter of cup. So we have a material required at this point. We have a material at this point, and we have material required at the bottom also. What is the total material required? Total material required at bottom is what? Pi by 4 into d square. How much is material required on circumference? Is it pi multiplied by d multiplied by height? Metal is also metal forming process. So material is wet. So whatever you require, this material must be equals to what? The material available with us, that is pi by 4 multiplied by dB square. So to make any cup like this without flanges, without round edge, can we find out the diameter of blank? It's a simple equation of what? Surface area balance. If we go by the radius calculation, it will be pi multiplied by RB, the radius of blank, and the area will be equals to pi r square, that is pi of r cup square. This is also cup, plus this one is 2 times pi into r cup multiplied by height. So pi will be get cancelled. This one is RB square. So can we calculate RB as under root of RC square plus 2 times RC multiplied. Suppose instead of this cup you want to make a hemispherical bowl. Suppose you want to make a hemispherical bowl. Forget about the thickness, and let's say the radius of this hemispherical bowl is r. So what is the surface area of sphere? 4 pi r square. Or hemisphere is what? 2 pi r square. So we have surface area is 2 pi r. Is balanced with what? The area of blank. Area of blank is what? Pi into RB square. Blank area is pi RB square, and hemisphere surface area is what? 2 pi r square. Your pi will get cancelled, and your RB is root 2 times of r. Fixed relation. This one is a cup with a flange. So this portion is called as flange. This one is cup height. Thickness I am not showing. Let's say this diameter is di or d1. This diameter is what? d2. Let's say this one is d2. The cup size is what? d1, and the height of the cup is what? h1. So what is the u required? Area at bottom. How much area required at bottom? Area required at bottom is pi by 4 into d1 square. How much area required for the side wall? That is the circumferential area. That will be equals to pi multiplied by d1 multiplied by h. And is this flange is basically a hollow circle. So that requires a material of pi by 4. Is it d2 square minus d1 square, and this area is to be balanced by the blank diameter. We can very well calculate the blanks. So this time we require a bottom area. Bottom area is what? Pi by 4 into d1 square, and circumferential area you can calculate using the mean diameter, that equal to pi into d1 plus d2 divided by 2 divided by h, and equate this with your blank diameter. Remember one thing, no part like this is produced. You always get a rounding. Sharp edges are not permitted. You always get a rounding. But this round is very small. In all this calculation, you neglect the radius, round radius. This is a very small portion. But in actual practice, they do consider the round, and they will subtract this value from this one. Something 0.5 r like that. For this you have to take the data book, handbook. Now, when you are doing the deep drawing operation, this job is placed on the die. Tool is pressed. The punch will move downward. But there is no shearing action. This die will be get pressed. But you are not getting the final cup in single stroke. For this, you have to require this number of stages. Suppose you are thinking that I will get the cup of this size. It's not possible in single draw. For this, you require multiple draw. So how you decide? You require a multiple draw. So for this one, we have a limitation. So we define one term called as drawing ratio. Right? Drawing ratio is defined as the diameter of blank divided by the diameter of cup. Diameter of blank to the diameter of cup. So initially we are having a blank like this of diameter equal to dB. Then you make the first draw. The first draw, the drawing ratio, we'll say beta value, is permissible is 0.5, that is 50% only. What is the meaning of this one? You can reduce this diameter to what? 50% in first draw. In second draw, you can reduce this to 30%. That is permitted. And if you require further, then you can go for third draw. That is 20%. So you are not getting your cup as a final position. It depends what is your cup diameter. So first this part will become this part. In second stage, the cup will become like this. If the diameter of cup is reduced and the height is increased. In the third stage, your diameter is decreased and your cup height is. If you want more depth, then you require more draw. If you require less depth, you can do it in the first draw itself. We have initially a 200 mm diameter. So we have a blank of 200 and we permit maximum value equal to what? 0.5. So maximum permissible is 0.5 is 1 minus. Whatever the cup diameter you are getting here, you labeled as D1. So 1 minus D1 divided by the original diameter of the previous stage. You can get 0.5 into 1 minus. We don't know what is the cup diameter here and what is the dB is 200. So you can solve this. So what is D1? Is it 100? So if you desired the cup less than 100, 100 or more than 100 or more than 100, then the first draw is. But if you want a cup less than 100 mm, then you have to go for second draw. So this time your reduction is what? 0.3. So for this stage our diameter is D2. You have to do this step, then this step. So this time reduction is 0.3. 1 minus D2 by D1. So this one is 0.3. 1 minus D2 was previous value. D2 we don't know. What is D1 is 100. So what do you get? D2 equal 70. You will get 70. Means anything you want from 70 mm to 100 mm, do you require 2 draws or 1 draw? Up to 70 to 100 हमको कितने draw लगेंगे? 2 draw लगेंगे. From 200 to 100, from 200, how many draw you require? 1 draw only. And from 70 to 100, you require 2 draw. If you go by the third draw, then what will happen? So this reduction is what again? 0.3. Now this time your diameter will become D3. So this is 1 minus D3 by D2, previous stage, 0.2 or 0.3. So this is 0.2. 1 minus D3 we want to calculate. D2 we got 70, maximum value. So what is the value of D3 we have? 56. So anything from 56 to 70, you require 3 draws. In a drip drawing, this surface, that is this part and this part, this section, you have to always make like this. If you make a sharp edges, a wrinkling effect will be there because the plate is suddenly changes this structure. This one is tensile force, this one is tensile force and this will be compressive force. So that it will try to break here. So cracking is very common at the bottom edge. Second thing, a flange like this. Suppose we are getting a flange in this fashion. Now when the flange is prepared, this part is stuck with the die and this part is get compressed. So because of this one, there is a cracking problem. This is a very common problem in a flange. So actually this part is hold in, this part is holder. Okay. So if this holder plate pressure is less, then the wrinkling problem is always. Secondly, if a solid material here and it will try to expand, it will push it this fashion. So this, how you get a wrinkle? You get a wrinkle like this shape will become like this. It's a curved shape. Or we have a crack development. Idea is clear? So this problem is always there. So normally this wrinkle is because of two criteria. First is decrease blank holder pressure. Blank holder pressure. So what is the remedy? If you do not run wrinkle, what is the remedy? You have to increase the blank holder pressure. Cause is this, cause is this. So what is the remedy? You have to increase it. Number 2. Now there is a passage restriction here because of this one. There are the stress produced, the compressive stress produced. So it will be like this, buckling. We called it as buckle. This portion will become waviness like this. That is get buckle due to buckling, due to circumferential compressive stress. Actually, what is buckling? If you have a rod like this, suppose we have a thin plate like this, and this side is fixed. This is a very thin member, and you apply this load. This load is same as compressive load. Because of this one, this member will try to bend this way. That is called as buckling. If it is under the elastic mode, it will come back to the original position. But in the plastic mode, it will make permanent shape like this. So that is why you are getting contour like that is not desirable. Now suppose they ask you that if no blank holder is used, if you are not using any blank holder here, then no stress is produced in flange. For hemispherical, if the radius is r, then the answer is 2r. What is the surface area of this? What is the surface area of hemisphere? 2 pi r. And what is the area of blank? Is pi r square. Pi into rb square. Rb is radius of blank. So pi will cancel and you will get rb equals. So this choice is correct. The diameter of the cup, the diameter of the blank required to produce a hemispherical cup of diameter equal to what? 0.1. You want to find out this. So in case of diameter, we will reduce to the hemispherical radius first. So hemispherical radius is 0.5. So blank will be required equal to what? Root 2 times r. So diameter of blank required will be equals to 2 times. It's simply 1.414. Root 2 is 1.414. Calculate the approximate blank diameter for a cup shaped component 250 mm diameter and 200 mm high. So we have given the diameter of the cup is what? 250 and the height of the cup is 200. We need to find out the diameter of blank. So you have to just equate the material required. So material required at the bottom plate will be equals to pi by 4 to d square, and for side wall material required is pi dh. The surface area of this one is pi by 4. So just substitute and solve it. Pi will get cancelled. So this is 1 by 4, 250 square, 250 multiplied by 200. Can solve this for diameter of blank. Answer is 512 mm. In this one we have given a cup. So cup, this has cup has a flange here, one vertical surface and one bottom circular surface. All dimensions are given. Thickness is 0.8 mm. You want to calculate thinning and spring back, and neglecting the corner radius and thinning of spring back. You want to find out diameter of blank. So this part consists of one bottom area. So bottom area will be equals to what? Pi by 4 into 40 square plus the circumferential area. Circumferential area is pi dh. Pi into 40 into h. H is 80 plus this hollow disc. Hollow disc has outer diameter equal to what? 60 and inner diameter equal to what? 40 plus pi by 4. 60 square minus 40 square. So this must equal to the area of blank, that is pi by 4 into db square. So again solve this for blank diameter. You should get 128.06. Choice D is correct. A symmetrical cup of circular cross section with a diameter equal to 40, height equal to 60 mm with a corner radius of 2 mm that you have to always neglect for calculation of blank, obtained by steel of 0.6 mm thickness. Calculate the blank size. You always neglect the corner radius and thickness idea. Do not bother about this one. Calculate the blank size for the cup drawn, and will it possible to draw the cup in a single step or multiple step? That is the question to you. So what is the diameter of cup? Diameter of cup is 40, height of cup is 60, and this one is diameter of blank. To find out the diameter, we will simply equate it. So surface area at bottom is pi by 4 d square, that is 40 square, plus circumferential area is pi into d into h. So pi into 40 into 60. This must equals to the area of blank, that is pi by 4 into db square. Solve this equation for the diameter of blank. Considering the first draw, assuming 50% reduction in first stage, in first draw. So we have 0.5 equals to 1 minus the diameter of the first stage divided by diameter of blank. So you can substitute for diameter of blank equal to what? 106 and solve for d1. So this answer come out to be 52.8. So is this diameter is more than the 40 mm diameter? It means that in the first stage your job will become something like this. So what is the diameter of cup now in the first stage? Is 52.9. So we'll go for second draw. Assuming 30% reduction in second draw. So we have 0.3 equals to 1 minus. So it is always d1 by db. So now the previous value is what? d1. So new value will be equal to what? d2 by d1. So d1 you have to put 52.9 and solve the value of d2, 37.1 mm. So anything from 32.7, 32.1 less than d less than 52.9 you can attain in 2 draw. So how many draw required? Is it possible to draw in single step or 2 steps? 2 steps. So you required minimum 2 draws. So a cup of 10 cm height. So we have a cup here of 10 and diameter is what? 5 cm. So first of all we'll equate the area. Same area as the bottom area is pi by 4 into d square is 5 square plus circumferential area is pi dh must equal to what is the blank diameter? 150 mm. So let's consider first draw. Take standard reduction equal to what? 50%. So 0.5, 1 minus diameter of cup in the first stage divided by blank diameter. From this find out value of D1 using blank diameter equal to 175 mm. This one is 15 cm. So this one is 7.5 cm. Whereas the required cup is what? Only of 5 cm. So this diameter is much more as compared to 5. So we will go for second draw. For second draw reduction is 30%. So we have 0.3, 1 minus D2 is the diameter after the second draw, and we have the first draw diameter is D1. Put D1 equal to 7.5 and get the value of D2 5.25. So 5.25 is still more than 5 cm. So you have to go for third draw. Reduction ratio in third draw is further reduced to only 20%. So we have 0.2, 1 minus. At the end of the third stage, we have diameter equal to D3 and this diameter is D2. Use D2 equal to 5.25, 4.2 cm. So 4.2 cm is less than 5 cm. So how many draws are required? 3 draws. So 3 draws are required for this operation. Why this is so? Because the cup height is too large. In the deep drawing operation, if deep drawing of cups, blanks show a tendency to what? Wrinkle round the periphery, that is a flange. So this one is a flange and this one is a cup. There is a formation of what? Wrinkles over here. Is this wrinkle formation is due to low pressure? Is it correct? Or due to what? Compression from this side. That is called as buckling load. But he want to say is what? The most likely cause and the remedy. Cause is what? Buckling due to what? Circumferential compression, and increase is what? What is the remedy for this? Increase the blank pressure. First is cause and second is what? Solution for it. Identify the stress state. You have to find out the stress of state. That is, you have to find out what type of stress is produced on the given element. In the flange portion, that is this portion, only in this portion, drawn without a blank holder. If you are not using a blank holder, no force is applied on this part. So any stress is produced or no stress is produced? No stress is produced because there is no blank.